Welcome, dear friend, to a journey beyond everything you know. Tonight, we're going to explore the multiverse, not the universe, but the multiverse, infinite realities, endless possibilities, worlds upon worlds, stacked like pages in a book that never ends. This isn't science fiction. These are real theories, proposed by the world's greatest physicists, born from the same equations that gave us smartphones and GPS satellites. So settle into your pillow, let your breathing slow, and prepare to drift through realities beyond imagination. If you enjoy these cosmic lullabies, a gentle like tells the universe you were here, and subscribing ensures more wonder finds you in the night. Now, close your eyes and let's begin. The multiverse theory suggests there might be more than 10 to the power of 500 different universes. That's a 1 followed by 500 zeros, a number so vast that if you wrote 1 0 per second, you'd need over 8 minutes just to write it down. To put this in perspective, there are only about 10 to the power of 80 atoms in our observable universe. The multiverse doesn't just dwarf our cosmos. It makes our entire reality a grain of sand on an infinite beach. And here's the beautiful mystery. We may never be able to prove other universes exist, yet the mathematics demands they do. But let's start with something stranger. You are living in a multiverse right now, according to quantum mechanics. Every decision you make splits reality into branches. When you chose what to eat for breakfast, the universe divided. One version of you had coffee, another had tea. Infinite use, living infinite lives, in a tree of possibility that grows faster than light itself. Physicist Hugh Everett proposed this in 1957, and the math has never been disproven. Your reality is just one leaf on an ever-branching tree. The concept emerged from trying to understand why particles behave so strangely. A single electron can exist in multiple places simultaneously until observed a phenomenon called superposition. Schrödinger's famous cat thought experiment illustrated this. A cat in a box is both alive and dead until you open the lid. But Everett asked a radical question. What if the cat doesn't choose? What if reality splits and both outcomes happen in parallel universes? Suddenly, quantum mechanics made perfect sense. Nothing collapses. Everything that can happen does happen, somewhere, somewhen, in the infinite garden of forking paths. This means there's a universe where dinosaurs never went extinct. They evolved, built civilizations, developed technology, and perhaps, right now, a dinosaur version of you is reading about mammals that might exist in alternate realities. The mathematics allows it. The probability, while microscopically small, is not zero. And in infinity, everything with non-zero probability becomes certainty. Somewhere, T-Rexes with opposable thumbs are pondering their existence under twin suns. Our universe is expanding faster than light itself, not through space, but as space. Galaxies at the edge of our observable universe are receding at 3.5 times the speed of light. This doesn't violate Einstein's rules, because they're not moving through space. The fabric of space itself is stretching like a balloon being inflated. This expansion creates cosmic horizons beyond which we can never see, no matter how long we wait. And behind those horizons, says cosmic inflation theory, other universe bubbles are forming, each with potentially different laws of physics. Imagine boiling water. Bubbles form, expand, and separate. Our universe is one bubble in an eternal, boiling cosmic foam. Physicist Alan Guth proposed this eternal inflation in 1980, and it's become the leading explanation for why our universe looks the way it does. The field that drove our Big Bang never fully shut off. It continues inflating in most regions of space, occasionally spawning new bubble universes. This process has no beginning and no end. It's been happening forever and will continue forever. We live inside one bubble moment in an infinite brew, the cosmic microwave background. The afterglow of our Big Bang contains a mystery. There's a cold spot 1.8 billion light-years across that shouldn't exist according to standard cosmology. One explanation: it's a bruise, the scar tissue from where another universe collided with ours in the first moments of creation. In 2015, researchers calculated that our universe might have bumped into another bubble universe when both were young and small, leaving this cold imprint across the sky. You can see the echo of another reality in the oldest light in our cosmos. But here's where it gets truly strange. Some physicists believe we live inside a black hole. Every black hole, from this perspective, contains an entire universe. When a star collapses and creates a black hole in our universe, it simultaneously creates a Big Bang in a baby universe on the other side of the singularity. This theory, proposed by physicist Lee Smolin, suggests universes reproduce like living organisms. Black holes are cosmic eggs. Our Big Bang was the birth cry from a black hole in a parent universe we can never contact. This creates an evolutionary multiverse. Universes with physics that produce lots of black holes make more baby universes. Over cosmic time, the multiverse would be dominated by universes fine-tuned to create black holes, which requires stars, which requires the same conditions needed for life. This could explain why our universe seems so precisely calibrated for complexity. We're not lucky, we're descendants, children of a cosmic lineage, billions of generations old, optimized by selection for the ability to create more universes. The fine-tuning of our universe is genuinely mind-bending. If the strong nuclear force were just 2% stronger, protons would fuse too easily, and there'd be no hydrogen, no water, no stars like our sun. 2% weaker, and protons wouldn't stick together at all, no atoms heavier than hydrogen. If gravity were slightly stronger, stars would burn too fast and die before life evolved. Slightly weaker, and stars wouldn't ignite at all. The universe balances on a knife's edge. Either we're impossibly lucky, or we're one possibility among countless others. There are potentially 10 to the power of 10 million different possible shapes for the extra dimensions predicted by string theory. Each shape would create a universe with different physical laws, different particles, different forces. String theory suggests our familiar 3 dimensions of space and 1 of time are just the visible surface of a 10 or 11-dimensional reality. The extra dimensions are curled up too small to see around 10 to the power of -35 meters. But how they curl determines everything: the masses of particles, the strength of forces, whether life is possible. This creates the string theory landscape, an incomprehensibly vast space of possible universes. Physicist Leonard Susskind argues that eternal inflation creates every possible universe in this landscape. Somewhere, a universe exists where electromagnetism is stronger than gravity. Somewhere else, there are 4 forces we've never imagined. And in rare pockets, like ours, the conditions align for stars, planets, chemistry, and consciousness. We inhabit a tiny island of habitability in an ocean of hostile physics. But perhaps the strangest implication, there's a universe where you made every different choice. The job you didn't take you took it in another branch. The person you didn't marry you did somewhere else. Every road not traveled by you here was traveled by you there. Quantum mechanics suggests that right now, as you listen to these words, countless other versions of you are living completely different lives. Some successful, some struggling, some having made the same choices through cosmic coincidence. You are not one person. You are a cloud of possibilities smeared across reality. The mathematics that describes our reality also describes countless others. The same quantum field theory that explains how electrons behave and how your phone works predicts the many worlds interpretation. Nobel laureate Steven Weinberg calculated that if the cosmological constant, the energy of empty space, were just slightly larger, the universe would have expanded so fast that galaxies could never form. We exist in a narrow window, but in a multiverse, narrow windows are guaranteed to exist somewhere. We couldn't exist in any other type of universe, so naturally, we find ourselves here. Here's a thought to drift on. Time might not exist in most universes. Our experience of flowing from past to future, of change and motion, requires very specific physics. In universes with different laws, there might be no sequential moments, no causation, no memory, just frozen mathematical relationships. We're blessed to live in a universe where time flows, where stories unfold, where sleep can lead to tomorrow. The ticking of time is not a given, it's a rare gift. Some cosmologists believe our universe is a hologram. The physics of black holes suggests that all information inside a volume of space can be encoded on the surface surrounding it, like a three-dimensional image projected from a two-dimensional surface. This holographic principle implies our three-dimensional reality might be a projection from a two-dimensional cosmic boundary. You're not inside the universe, you're encoded on it. The boundary between universe and multiverse might be thinner than we think, perhaps just a dimension away, literally. If our universe is infinite in space, as many cosmologists believe, then the multiverse isn't some exotic idea, it's guaranteed by pure mathematics. In an infinite space, every possible arrangement of matter must occur infinitely many times. That means there's another Earth out there, identical to ours, down to the last atom. And another where you wore different socks this morning. And another where humans never evolved. Infinity makes the impossible inevitable. The simulation hypothesis offers another flavor of multiverse. If it's possible to create detailed simulations of universes, and if civilizations often survive long enough to create many such simulations, then statistically, we're almost certainly inside a simulation right now. For every one real universe, there might be millions of simulated ones. Philosopher Nick Bostrom proved this mathematically. Either civilizations usually go extinct before developing this technology, or they choose not to create simulations, or we're in one. One of these three must be true. If we're simulated, the multiverse is the library of all possible simulations being run on some incomprehensible computer in a higher reality. Our Big Bang was the start button. Physical laws are the program's code. And somewhere, on hardware we can't comprehend, our entire history is a running process. This doesn't make our experiences less real. The simulation is our reality. But it suggests our universe is one file in an infinite directory, one game in an endless arcade. Here's something soothing. in the many worlds interpretation. You're immortal from your own perspective. Every time you face a potentially fatal event, reality branches. In branches where you die, you cease to experience, but in branches where you survive, you continue. From your subjective experience, you always find yourself in the branch where you survived, no matter how improbable. You ride the branch of quantum immortality, surfing the wave of possibility where you exist. Though loved ones may grieve in branches where you died, you only ever experience the branches where you continue. This is called quantum suicide, a thought experiment, not to be taken as life advice, but as a window into how strange reality might be. If many worlds is correct, your consciousness always follows the branch where it exists. You're automatically selected into the timeline of your survival. It's not that you're special, it's that you can only ask these questions in realities where you exist to ask them. The multiverse is full of your ghosts, but you're guaranteed to be elsewhere. The observable universe contains about 100 billion galaxies. Each galaxy contains, on average, 100 billion stars. That's 10 sextillion stars. 10 oh 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 oh, and in the multiverse, that staggering number describes one bubble, one branch, one mathematical structure. The total number of stars across all universes is, under most multiverse theories, literally infinite. Not just practically infinite, or might as well be infinite. Actually, mathematically infinite. You can count forever and never finish. Every star, a potential hearth for life, for consciousness, for other beings pondering their place in the cosmic foam. But infinity has strange properties. There are different sizes of infinity. The infinity of integers, 1, 2, 3, 4, ... closing parenthesis, is smaller than the infinity of real numbers, all the decimal points between 1 and 2. Mathematician Georg Cantor proved this, and it nearly broke his mind. The multiverse might contain layers of infinity, stacked on each other, infinite universes, each with infinite space, each with infinite quantum branches, each embedded in an infinite number of mathematical structures. Infinity within infinity, within infinity, like mirrors reflecting mirrors into eternal depth. Does this make you insignificant? Some would say yes, but consider, in an infinite multiverse, you are also infinite. Infinite versions of you making infinite choices, living infinite lives. Your existence is multiplied beyond number. And here, in this version, this universe, this moment you're listening to these words, this specific configuration of atoms, thoughts, and experiences is unique even in infinity. Because while you repeat infinitely, the specific details around you this exact moment, this precise thought, might be rare. You are both common and precious, both cosmic dust and irreplaceable. The anthropic principle states that we observe the universe to be compatible with life because we're here to observe it. In universes incompatible with life, nobody's asking why. This seems obvious until you realize its profound implication. Our observations tell us nothing about how rare or common life-friendly universes are. We're trapped in selection bias. We can only exist in the tiny fraction of universes, branches, or regions where existence is possible. The multiverse might be 99.9999% hostile to life, but we'd never know from inside our bubble. Some physicists hate the multiverse idea because it seems unfalsifiable. How can you test for other universes if, by definition, we can't access them? But others argue we're already seeing evidence. The cosmic microwave background, cold spot, the fine-tuning of physical constants, the mathematical necessity of quantum branching. The multiverse isn't a failure of science. It's the logical conclusion of our best theories. We didn't seek it. The equations led us here. In 2015, researchers thought they found evidence of gravitational waves from the Big Bang itself, the first tremors of inflation. Though that specific signal turned out to be dust, the search continues. If we detect primordial gravitational waves, they'd confirm inflation happened. And if inflation happened, eternal inflation is almost certain, which means bubble universes are real. We might prove the multiverse indirectly by confirming the mechanism that creates it. The evidence wouldn't be another universe. It'd be the cosmic factory that makes them. String theory requires extra dimensions, tightly curled spaces far too small to see. But in some models, these dimensions might be enormous in other universes. Imagine a universe where one of those extra dimensions is stretched out large enough to walk through. Gravity would behave completely differently. Matter might be unable to clump into stars. Or perhaps consciousness could exist in forms we can't fathom, beings that move through dimensions we can't access, for whom our three-dimensional space is a confining sheet they can step above or below. The quantum field theory that governs particles suggests every point in space contains fields electromagnetic, quark, lepton, Higgs, and others. These fields vibrate, and their vibrations are particles, but the fields themselves are everywhere always. You're swimming through quantum fields right now. They pass through your body, the solar system. In other universes, there might be different fields, creating particles we've never seen, forces we've never felt, phenomena we can't name. The field structure of reality is not a given. It's a local accent in the cosmic conversation. The Higgs field gives particles mass. Before the Higgs field turned on shortly after our Big Bang, particles zipped around at light speed, massless and free. When the field settled into a particular state, it began interacting with particles, slowing them down, giving them inertia, what we call mass. But the Higgs field could have settled into a different state, giving different masses to particles. In most possible states, atoms couldn't form. We live in a universe where the Higgs field happened to land in a mass-friendly configuration. Elsewhere, it landed differently, creating universes of pure light or collapsed into black holes. Imagine a universe where gravity is 1 trillion times stronger. Stars would be planet-sized, burning their fuel in days instead of billions of years. Planets couldn't exist, they'd collapse into black holes. Life, if possible at all, would need to think at light speed to experience anything before its star died. Or imagine gravity 1 trillion times weaker. Gas clouds would never collapse to form stars. The universe would be a cold, dispersed mist of hydrogen drifting apart forever. Our gravity is a narrow Goldilocks zone in an infinite spectrum of possible gravities. The cosmic coincidences pile up. The ratio of electromagnetic force to gravitational force is about 10 to the power of 40. If it were different, stars would behave radically differently. The masses of the electron and the proton have a precise ratio that allows stable atoms. The strength of the strong nuclear force sits in a narrow band where atomic nuclei can form without everything fusing into iron. Each dial on the cosmic control panel is set to a life-permitting value. Either we won a lottery with trillions of tickets, or all combinations exist, and we're naturally in one that works. Carbon, the backbone of life, is created in stars through a remarkable resonance. Helium nuclei fuse in a star's core, briefly forming beryllium, which immediately captures another helium to become carbon. This only works because carbon's nuclear energy levels happen to line up perfectly. Change the strong force slightly, and this resonance vanishes. No carbon, no organic chemistry, no life as we know it. Astronomer Fred Hoyle predicted this resonance before it was measured, reasoning that since we exist, it must exist. The universe seems calibrated for our presence. Or perhaps we're calibrated for the universe. Evolution optimized our brains to understand three-dimensional space, linear time, medium-sized objects moving at medium speeds. We evolved to dodge predators and find fruit, not to grasp quantum fields or curved spacetime. That we can understand anything about the multiverse is remarkable. But we're likely missing most of it. Unable to perceive dimensions, forces, or realities our neurology never needed to represent. We're fish trying to understand the ocean, not realizing we're also missing the land, sky, and space beyond. In the many worlds interpretation, every possible history has occurred. There's a branch where the asteroid missed the dinosaurs, and evolution took a different path. A branch where the Library of Alexandria never burned, and human technology advanced 1,000 years earlier. A branch where you're a completely different person because a single quantum event in your grandmother's ovaries determined a different sperm fertilized a different egg. History isn't a line, it's a bush branching fractally backward and forward through time. Some branches are more probable than others. Quantum mechanics gives probabilities, and likely branches are thicker, containing more copies of you. Unlikely branches are thinner, with fewer copies experiencing those improbable events. You exist in all branches, but most of your experiential weight lies in probable branches. The thinner branches still exist, including ones where you've experienced wildly unlikely events. But most versions of you are clustered around typical experiences, living statistically normal lives in an infinite forest of possibility. The timeline you experience feels smooth and continuous, but it's actually a path through quantum branching. Every plonk, time about 10 to the power of -44 seconds reality splits. That's the smallest meaningful unit of time. Between any two moments you experience, reality has branched more times than there are atoms in your body. You're not riding one timeline. You're surfing a wave function through an ocean of possibility, always moving toward branches where you continue to exist and observe. Here's a peaceful thought. Somewhere in the multiverse, a version of you is perfectly happy. Every regret you have, some other you avoided. Every dream deferred in this timeline, some other you fulfilled. The multiverse contains your best possible life and your worst, and every gradation between. You're not just this person in this place with these worries. You're a spectrum of experiences stretched across infinity. And in the branches, you can influence the future. Spreading from this moment, you still have power to choose. The opposite is also true, which brings its own strange comfort. Somewhere, a version of you is experiencing the worst timeline. They carry regrets you avoided. They face hardships you escaped. In the vast landscape of possibility, your current experience is likely somewhere in the middle, neither the best nor the worst. This very thought can bring peace. Whatever you're facing, it could be worse, and in infinite branches it is. You're on one path among many, and it's neither the summit nor the abyss. Physicists estimate that in an infinite universe, the nearest identical copy of Earth would be about 10 to the power of 118 meters away. That's 1 followed by 118 zeros in meters, a distance so vast that it makes the observable universe look like a grain of sand. At that distance, every quantum fluctuation since the Big Bang has had time to arrange atoms in the exact same pattern as here. Same planet, same history, same you, reading the same words at the same moment. But you can never reach them or confirm they exist. They're real, but forever beyond the horizon of possible contact. This assumes our universe is infinite in space, which current observations suggest is likely. The universe appears geometrically flat, and in an eternally inflating multiverse, flat universes tend to be infinite. But even if our universe is finite, the multiverse of eternal inflation and quantum branching is certainly infinite. Infinity is hard to escape once it enters your cosmological models. One way or another, the mathematics keeps generating endlessness. Some theoretical physicists propose that consciousness itself might be fundamental to reality, not emergent from matter. In this view, awareness is woven into the fabric of the multiverse, and complex brains like ours simply focus and concentrate it, like lenses focusing light. Other universes might have different consciousness structures, group minds, field-based awareness, or forms of experience we cannot imagine because our consciousness is trapped in individual, embodied form. The multiverse might be dreaming itself into existence through infinite perspectives. The quantum Zeno effect shows that observation can freeze quantum systems. Watch a quantum system continuously, and it can't evolve or change. It's frozen by observation. Some interpretations suggest consciousness collapses wave functions, choosing branches in the quantum multiverse. If true, your awareness is actively selecting which branch of reality you experience, moment by moment. You're not a passive observer riding predetermined tracks. You're an active participant steering through possibility space, though the mechanism remains mysterious. Every choice you make is, in a sense, universe selection. When you decide to be kind, you move toward branches where kindness exists. When you choose learning over ignorance, you navigate toward more enlightened timelines. You can't control quantum branching, particles will split regardless, but your conscious choices steer the probability distribution of which branches you're most likely to experience. The future is a garden of forking paths, and you're the gardener, though you can only tend the section beneath your feet. In the block universe view of time, all moments exist simultaneously. Past, future, and present are all equally real, like frames in a film. Combined with the many worlds interpretation, this creates a four-dimensional multiverse where every possible timeline exists as a static mathematical object. Nothing changes. We simply move our awareness through it like reading a book. The story was always there, beginning to end, and you're the reading consciousness, experiencing it page by page, though all pages exist at once. This dissolves the paradox of free will. Your choices are reluged, genuinely decide between alternatives. But from the perspective of the eternal multiverse, all your choices have already happened, are happening, and will happen in the timeless mathematical structure. Determinism and free will coexist because time is an illusion of consciousness, and the multiverse contains all possibilities simultaneously. You're both the author and the reader of your story. Some branches of string theory predict brain worlds. Our universe exists on a three-dimensional membrane floating in higher dimensional space. Other membranes float nearby, separated by tiny distances in the extra dimensions. These parallel brains might be millimeters away in a direction we can't point to because it's not in our three dimensions. Occasionally, brains collide, and some cosmologists think our Big Bang was such a collision. Other universes aren't far away. They're right here, displaced in dimensions we can't access. Gravity might leak between brains, which could explain why gravity is so much weaker than the other forces. The electromagnetic force binding atoms is 10 to the power of 40 times stronger than gravity holding you to Earth. Why such an enormous gap? Perhaps because gravity dilutes across extra dimensions, spreading into the bulk space between brains, while the other forces are confined to our brain. Other universes might be stealing our gravity, and we're stealing theirs. Invisible neighbors sharing forces across dimensional walls. The cosmological constant problem is one of physics' greatest mysteries. Quantum field theory predicts empty space should have enormous energy, 10 to the power of 120 times what we observe. Yet measurements show it's nearly zero, with just a tiny positive value that makes the universe expand. This discrepancy is the worst prediction in scientific history. Unless you invoke the multiverse, if every possible value of vacuum energy exists across universes, and only very small values allow stars and galaxies to form, we'd naturally find ourselves in one of the rare universes with life-permitting vacuum energy. This is the landscape solution to fine-tuning. You don't need to explain why our universe has improbable values. You just need a mechanism to generate all values. Eternal inflation does that. String theory provides 10 to the power of 500 possible vacuum states. Together, they create a multiverse where every combination exists, and observers only arise in the rare combinations that work. It trades one fine-tuned universe for countless universes spanning all possibilities. Many physicists find this satisfying. Others consider it a capote. The debate continues. Imagine you could communicate across universes. You'd face an immediate problem. Which branch to contact? In the quantum multiverse, there are far more branches where you don't exist than where you do. Most branches split before your conception, before Earth formed, before the sun ignited. Most of reality has no idea you exist. And in branches where another you exists, they're living different lives, facing different choices. What would you even say to a self who made every opposite choice? Would you recognize each other as the same person? This touches on personal identity philosophy. Are you defined by your atoms, which are constantly replaced? Your memories, which shift and fade? Your choices, which could have been different? In a multiverse, identity becomes fluid. You're a cloud of possibilities, a distribution across branches. The essential you might be something deeper, pattern, a process, a particular way of organizing matter and information. That pattern instantiates countless times across the multiverse, but each instance is a legitimate you, not a copy. You are the pattern, not the particular atoms temporarily embodying it. The heat death of our universe is likely trillions of years away when all stars burn out. All black holes evaporate, and everything reaches maximum entropy, a cold equilibrium where nothing can happen. But in the multiverse, other universes are forming constantly. While ours ages and dies, Fresh Big Bangs are igniting elsewhere, creating new realms where complexity can emerge, where life can begin, where consciousness can wonder about its place in existence. The multiverse is eternally young, eternally old, eternally in every phase, simultaneously across its infinite expanse. Some cosmological models suggest universes can form from quantum fluctuations in the vacuum. In a region of ultra-high-density energy, quantum uncertainty allows a tiny pocket of space-time to tunnel into a lower energy state, triggering inflation that blows it up into a full universe. This might happen spontaneously and eternally. Our Big Bang wasn't the first and won't be the last. Universes are being born constantly, each from quantum tunneling events in the seething vacuum of other universes or the space between them. This creates a genealogy of universes. Ours was born from a fluctuation in ... something, perhaps another universe, perhaps a primordial void with different physics. We might create child universes in our black holes, each with slightly different physics determined by the black hole's properties. Those child universes might create their own offspring. The multiverse becomes a tree of creation, branching and expanding, each universe a node in an infinite family tree stretching back eternally and forward forever. The ultimate question: why is there something rather than nothing? In a multiverse, this question dissolves. If every mathematical structure exists, then nothing is just one possibility among infinite somethings, and it's vastly outnumbered. Or perhaps nothing is unstable. Quantum mechanics shows that true emptiness can't exist. Virtual particles constantly appear and disappear in the vacuum. Nothingness decays into somethingness. The multiverse might be inevitable, the natural state of reality, and the question should be reversed: how could there be nothing? In the quantum realm, particles don't have definite positions until measured. An electron orbiting an atom exists as a probability cloud simultaneously everywhere it could be, with different likelihoods. Only when you observe it does the cloud collapse into a specific location. But the many worlds interpretation says it doesn't collapse at all. Instead, reality splits into every possible outcome, each with a probability determined by quantum mechanics. The electron appears in different places, in different branches, and you, the observer, split to each version of you seeing a different result. This means measurement doesn't reveal reality. It creates your branch of it. Before you look, the electron genuinely exists in multiple states. After you look, multiple versions of you exist, each having seen different states. Nothing collapsed, everything happened. The wave function is reality itself, not merely a description of what we know. This interpretation sounds like science fiction, but mathematically, it's the simplest explanation. It requires no mysterious collapse mechanism, no special role for consciousness, no spooky action at a distance, just pure quantum mechanics taken seriously. The double-slit experiment demonstrates this eerily. Fire electrons, one at a time, through two slits, and they create an interference pattern on a detector screen proof. They went through both slits simultaneously as waves, but place a detector at the slits to see which one the electron uses, and the interference pattern vanishes. The electron suddenly behaves like a particle, going through only one slit. Observing changes the outcome. In many worlds, both outcomes happen. Branches where it went left, branches where it went right, and branches where it remained wave-like because nobody looked. The universe accommodates all possibilities. Quantum entanglement connects particles across any distance. Measure one particle's spin, and its entangled partner instantly has the opposite spin, even if it's on the other side of the galaxy. Einstein called this spooky action at a distance and believed it proved quantum mechanics was incomplete. But experiments have confirmed it's real. Information doesn't travel between the particles that would violate relativity. Instead, the two particles share a single quantum state. They're one system spread across space. Measuring one doesn't affect the other. It reveals correlations that were always there, woven into the fabric of their shared reality. In the many worlds interpretation, entanglement creates branches too. When you measure one particle, reality splits based on its possible spins. Your measurement device entangles with the particle, then you entangle with the device, then the environment entangles with you. The branching spreads like a wave, creating consistent universes where all entangled observations agree. On the other side of the galaxy, when someone measures the partner particle, their reality branches consistently with yours. The multiverse maintains mathematical coherence. All branches obey the same quantum rules, ensuring the correlations Einstein found so spooky. Decoherence explains why we don't see quantum superposition in everyday life. Large objects constantly interact with their environmental molecules, photons, thermal radiation. Each interaction entangles the object with its surroundings, rapidly splitting reality into branches where the object has definite properties. A cat can't remain in superposition because it's constantly interacting with the air around it, the box containing it, the photons bouncing off it. Within microseconds, reality branches into states where the cat is definitely alive or definitely dead. Superposition doesn't vanish, it just becomes imperceptible as coherent branches. The decoherence time for a dust particle at room temperature is about 10 to the power of negative 31 seconds. That's the time it takes for environmental interactions to force it into a definite state. For a virus, it's about 10 to the power of negative 13 seconds. For a human, instantaneous by any measurement we can make. We're too large and too warm to maintain quantum coherence. Our classical reality emerges from quantum reality through constant environmental monitoring. The universe measures us trillions of times per second, branching us into definiteness. Yet quantum effects still matter for consciousness. Neurons fire based on ion channels that may involve quantum tunneling. Microtubules in neurons might maintain quantum coherence for brief moments. Some researchers propose quantum processes in the brain could be relevant to decision-making, though this remains controversial. But even if our thoughts are purely classical, they're built from quantum components. Every atom in your brain is a quantum system, following quantum rules, splitting reality constantly. Your consciousness rides atop a churning quantum ocean, stable only because decoherence smooths the waves into apparent certainty. The Schrödinger equation, which governs quantum mechanics, is completely deterministic. Given an initial state, it predicts all future states with perfect accuracy. There's no randomness in the equation itself. The apparent randomness comes from our subjective experience of being in one branch rather than another. From outside the multiverse, such a perspective existed. Everything is deterministic and predictable. But from inside, trapped in one branch, unable to observe the others, we experience irreducible randomness. Probability is subjective in a multiverse, an artifact of limited perspective. This resolves Einstein's discomfort with quantum mechanics. He famously said, God does not play dice with the universe. And in many worlds, God doesn't. The dice are an illusion. Every outcome happens. The universe doesn't choose. It includes all choices. Einstein wanted determinism, and many worlds gives it to him, not the determinism of a single timeline, but the determinism of all timelines existing in a perfect mathematical structure. No randomness, no collapse, no mystery, just the complete wave function evolving according to Schrödinger's equation, forever and always. But this creates a measure problem. In an infinite multiverse, everything that can happen does happen infinitely many times. How do you calculate probabilities when all outcomes occur infinitely often? Physicists define measure, the relative weight or thickness of branches. More probable outcomes have higher measure. They comprise more of reality's volume. When you make a quantum measurement, you're more likely to find yourself in high measure branches simply because more of reality goes there. You exist in all branches, but most of your experiential weight lies in probable outcomes. Imagine the multiverse as an infinitely branching tree. The trunk is the initial state. Every quantum event creates a fork, splitting into branches. Probable outcomes create thick branches. Improbable outcomes create thin twigs. You exist on every branch and twig, but there's more of you, more copies, more measure on the thick branches. When you experience a probable outcome, it's because that's where most of you lives. The improbable outcomes still happen to some version of you, but those versions are outnumbered by the more typical experiences. The Born rule in quantum mechanics states that the probability of an outcome equals the square of the amplitude in the wave function. This rule is mysterious. Why square? Why not cube or some other function? But in many worlds, the Born rule might emerge naturally from how observers like us are distributed across branches. If your subjective experience is proportional to the quantum amplitude squared, you'll naturally find yourself in branches weighted by that amplitude. The Born rule isn't added to quantum mechanics. It's how it feels to be an observer in the quantum multiverse. Some physicists have derived the Born rule from decision theory. If you're a rational agent in a branching universe, trying to maximize your expected utility across branches, you should act as if probabilities follow the Born rule. This connects quantum mechanics to rationality and self-interest. The universe's probabilistic nature emerges from the optimal way to make decisions when you exist in multiple branches. Your intuitive sense of probability might be a cognitive adaptation to living in a multiverse, evolution's solution to navigating branching reality. Quantum computers exploit superposition to process information. A classical bit is either 0 or 1. A quantum bit, a qubit, can be both simultaneously, existing in superposition until measured. 2 qubits can be in 4 states at once. 3 can be in 8. N qubits can represent 2 to the power of n states simultaneously. A 300-qubit quantum computer could process more states than there are atoms in the observable universe. It achieves this by spreading computation across the quantum multiverse, effectively borrowing processing power from parallel branches. David Deutsch, a pioneer of quantum computing, describes it explicitly in many worlds terms. Quantum computers prove parallel universes exist because there's nowhere else for the computation to happen. When a quantum computer factors a large number, where did the computational work occur? Not in the single timeline we observe. The qubits are too few to process so much information. The work happened across branches, with different versions of the computer testing different factors simultaneously, then the results interfering to give us the answer. We're seeing evidence of parallel computation in parallel universes. This doesn't mean we can communicate with other branches. The branches are isolated by decoherence. Information can't flow between them. But quantum computers can create and exploit interference patterns before decoherence sets in, briefly harnessing the multiverse's computational power. It's like reaching through the dimensional walls to borrow resources, then pulling back before the walls solidify. We can't visit other branches, but we can use their physics to solve problems faster than classical reality allows. Quantum supremacy, the point where quantum computers outperform classical ones, was achieved by Google in 2019, using a 53-qubit processor to solve a specific problem in 200 seconds that would take the world's best supercomputer 10,000 years. That computational power came from somewhere. In many worlds, it came from parallel branches. The quantum computer, entangled with 2 to the power of 53 parallel versions of itself, each exploring different solution paths, then combined the results through quantum interference. This isn't proof of many worlds other interpretations exist, but it's certainly suggestive. Inflation theory explains why our universe is so uniform. In the first fraction of a second after the Big Bang, space expanded, exponentially doubling in size at least 90 times in about 10 to the power of -32 seconds. This took a tiny, uniform patch of space and blew it up to encompass our entire observable universe. Any initial irregularities were smoothed out by the expansion. That's why the cosmic microwave background looks the same in all directions. It all came from one tiny patch that was causally connected before inflation separated it beyond light-speed communication. But inflation doesn't stop everywhere at once. In most regions, inflation continues. Only occasionally does it slow and stop, creating a bubble universe like ours. Meanwhile, the inflating regions keep expanding and spawning more bubbles. This is eternal inflation. Once it starts, it never completely stops. The inflating space grows faster than bubbles form within it, so there's always room for more universes. It's been happening for eternity past and will continue for eternity future. Our universe is one moment in an infinite cosmic process. Alan Guth, who proposed inflation in 1980, realized it must be eternal. The quantum fields driving inflation fluctuate randomly. In some regions, the field drops to a lower energy state, ending inflation and creating a bubble universe. But in other regions, quantum fluctuations push the field higher, causing even faster inflation. The regions that inflate faster produce more volume, creating more space where more bubbles can form. It's exponential growth. The multiverse reproduces faster than bubble universes can fill it. Each bubble universe might have different physical laws. During inflation, various fields settle into different states, like balls rolling down a hill with many valleys. Which valley the field settles into determines the properties of that universe: particle masses, force strengths, the cosmological constant. String theory suggests there are 10 to the power of 500 possible valleys. Eternal inflation explores all of them, creating bubble universes with every possible physics. Somewhere, a universe exists where electrons are heavier than protons. Somewhere else, there are 5 fundamental forces. Most are sterile, but in the vast space of possibilities, life-permitting universes like ours inevitably exist. The distance to the nearest other bubble universe is likely beyond our cosmic horizon, the boundary of our observable universe, currently about 46 billion light-years away. We can never see beyond this horizon because light from further away hasn't had time to reach us. The universe is only 13.8 billion years old, and it's been expanding. So even if another bubble universe exists, we probably can't detect it directly. We're isolated in our bubble, surrounded by inflating space that pushes other bubbles away faster than light can bridge the gap. But occasionally, bubbles collide. When two bubble universes expand into each other, they leave a marked disc-shaped pattern in the cosmic microwave background. Researchers have searched for such patterns and found a few candidates, though none are statistically significant enough to confirm. The cold spot mentioned earlier might be a collision scar, or it might just be a statistical fluke. More data is needed, but the possibility exists. We might be able to see the bruise from where another universe bumped into ours in the first moments of creation. If we could visit another bubble universe, we might find physics so different that matter as we know it can't exist. You'd disintegrate instantly, your atoms unable to hold together under alien forces. Or perhaps time flows differently, faster, slower, or not at all. You might experience a billion years in a second, or freeze in timeless stasis. Most bubble universes are hostile to complexity, let alone life. We're in a rare pocket of habitability, surrounded by an infinite multiverse of mostly barren or incomprehensible physics. The cosmic microwave background is the oldest light in our universe, released 380,000 years after the Big Bang when the universe cooled, enough for atoms to form and photons to travel freely. It's a baby picture of our universe, showing tiny temperature variations that eventually grew into galaxies. But it also might contain messages from the multiverse. Patterns that don't fit standard cosmology, and asymmetries, unexpected alignments, could be signatures of other universes influencing ours through collisions, gravitational effects, or more exotic interactions. One anomaly: the universe appears slightly lopsided. The cosmic microwave background has more large-scale structure on one side of the sky than the other. Standard cosmology predicts perfect symmetry. Some researchers speculate we're feeling gravitational pull from structures outside our observable universe, perhaps a concentration of other bubble universes in one direction, pulling on the matter in our cosmos. This is speculative, but it's testable. Better measurements of the microwave background and large-scale structure might reveal patterns that point beyond our horizon. Dark energy makes up 68% of the universe's energy. It's the mysterious force accelerating the universe's expansion, pushing galaxies apart faster over time. We don't know what it is. The leading candidate is vacuum energy, the cosmological constant, the energy of empty space itself. But why does it have the value it does? It's fine-tuned to 120 decimal places. Change it slightly, and galaxies couldn't form. In a multiverse, this fine-tuning is explained by selection. We observe a small cosmological constant because only universes with small values produce observers. But here's a puzzle. Our cosmological constant is suspiciously small, but not zero. It's roughly the same order of magnitude as the matter density in our universe. This coincidence is troubling. Why did dark energy become dominant just recently in cosmic history, just as stars and galaxies matured, just as life evolved? If the multiverse contains all values, Why do we find ourselves in a universe where dark energies' influence kicked in at this seemingly special time? Some physicists think this points to deeper structure in the landscape of possibilities, patterns we haven't yet discerned. Dark matter comprises 27% of the universe, and we don't know what it is either. It doesn't emit, absorb, or reflect light. It only interacts through gravity, its invisible scaffolding that holds galaxies together. Without it, galaxies would fly apart. Stars would never have clustered enough to form. Leading candidates include WIMPs, weakly interacting massive particles, ixions, or even primordial black holes. But in a multiverse, some universes might have different dark matter, or none at all. We're in a universe with the right type and amount of dark matter to build galaxies, which makes sense. Observers need galaxies to emerge. The remaining 5% of the universe is ordinary materiatoms, the stuff of stars and planets and people. Everything we've ever seen, touched, or measured is a small fraction of reality's content, and that's just in our universe. Across the multiverse, ordinary matter's proportion might vary wildly. Universes dominated by dark energy would expand too fast for structure to form. Universes dominated by dark matter might collapse into black holes. We're in a rare equilibrium where all three components balance delicately enough for complexity to arise. Imagine a universe with no dark energy. Gravity would eventually halt expansion and reverse it, pulling everything back together in a big crunch. Depending on that universe's age, it might have time for stars to form and life to evolve before the contraction. Civilizations there would face an ultimate deadline, the day when galaxies collide, stars merge, and everything compresses back into a singularity. Would they accept their fate or desperately search for escape? In our universe, we face expansion and heat death, instead different doom, same finality, unless the multiverse offers exits we haven't imagined. String theory attempts to unify quantum mechanics and general relativity by proposing that particles aren't points, but tiny vibrating strings. Different vibration patterns produce different particles. An electron is one pattern, a quark another, a photon a third. The strings vibrate in 10 or 11 dimensions, most curled up far too small to detect. This sounds bizarre, but it's the leading candidate for a theory of everything, mathematically consistent and potentially explaining all forces and particles from one fundamental object, the string. But string theory has a problem. It doesn't make unique predictions. There are roughly 10 to the power of 500 ways the extra dimensions can curl up, each producing different physics. For decades, physicists hoped to find the one right configuration, the unique shape that matches our universe. Instead, they found a landscape of possibilities. Some viewed this as a failure, but combined with eternal inflation, it becomes a feature. All configurations exist across the multiverse. String theory doesn't predict our universe's physics. It predicts the space of all possible universes, and we're one point in that space. The strings themselves are about 10 to the power of -35 meters long, the Planck length, the smallest meaningful size. At this scale, space and time break down into quantum foam, a seething froth where geometry fluctuates wildly. Below the Planck length, our concepts of distance and duration lose meaning. It's like zooming in on a photograph until you see individual pixels. Zoom further and there's nothing, just the grain of reality itself. Strings dance at this boundary between something and nothing. their vibrations creating the illusion of particles in smooth spacetime. If you could grab a string and stretch it, it would resist with enormous tension, about 10 to the power of 39 tons. That's a billion tons of force. This tension is why strings behave like they do, snapping into particular vibration modes. It's also why we can't detect them directly. You'd need energies far beyond any particle accelerator to probe Planck scale distances. Strings are hidden not by distance, but by scale, existing everywhere but at sizes forever beyond our experimental reach. M-theory unifies different versions of string theory into one framework by proposing an 11th dimension. In this theory, strings can expand into membranes, brains that exist in higher dimensions. Our universe might be a three-dimensional brain floating in an 11-dimensional space. Other brains float nearby, parallel universes separated by tiny distances in the extra dimensions. We can't see or touch them because we're confined to our brain, like characters drawn on a sheet of paper, unable to perceive other sheets stacked above and below. Gravity might be unique among forces in being able to propagate through the bulk space between brains. This could explain why gravity is so weak compared to other forces it dilutes across dimensions we can't access. When you drop something, it accelerates at 9.8 meters per second squared because most of gravity's strength is leaking into the extra dimensions. In a universe without this leakage, gravity might be as strong as electromagnetism, dramatically changing physics and making stars burn differently, planets behave bizarrely, and life impossible as we know it. Some brain world models propose that colliding brains create big bangs. Two brains drifting in the bulk space occasionally collide, releasing enormous energy that manifests as a big bang on each brain. Our universe might have been born from such a collision trillions of years ago in brain time. The brains then separate, cool, and drift until the next collision, creating an oscillating cosmology and eternal cycle of big bangs, expansions, collisions, and rebirths. Time extends infinitely backward and forward, with our universe just one pulse in an eternal cosmic heartbeat. Kaluza-Klein theory, dating back to the 1920s, showed that adding a fifth dimension to Einstein's equations automatically produces electromagnetism. Gravity in 5 dimensions looks like gravity plus electromagnetism in 4 dimensions. This remarkable result suggested that forces might be geometric different aspects of how spacetime curves in higher dimensions. String theory extends this idea. All forces and particles are geometric patterns in 10 or 11-dimensional spacetime. Reality is pure geometry, and what we call physics is just the shape of higher dimensional space. If the extra dimensions were large enough, we could potentially access them. You could step up out of our 3-dimensional brain into the bulk space. From there, you'd see our universe as a 3-dimensional surface embedded in a higher space. You could see inside closed boxes without opening them, appearing to teleport by moving through dimensions we can't access. But experiments show any large extra dimensions must be smaller than about 0.1 millimeters, or we'd have detected gravitational anomalies. The extra dimensions, if they exist, are either incredibly tiny or cleverly hidden from our best experiments. Some theorists propose warped extra dimensions that are large but geometrically warped in ways that make them hard to detect. Imagine a dimension curved so extremely that traveling a short distance in our dimensions takes you a huge distance in the extra dimension, or vice versa. Such warped geometry could hide large dimensions in plain sight, explaining various mysteries of particle physics and potentially even offering pathways to other universes accessible through exotic geometry. The holographic principle suggests our universe is a projection from a lower dimensional boundary. This comes from black hole physics. A black hole's entropy, the maximum information it can contain, is proportional to its surface area, not its volume. That's strange. It suggests the information about everything inside the black hole is encoded on its two-dimensional event horizon. Physicists realized this might be true for any region of space. All the information about a volume might be encoded on its bounding surface, applied to the universe. This means our three-dimensional reality might be a hologram projected from information encoded on a distant two-dimensional surface, perhaps the cosmic horizon, the boundary of our observable universe. Your thoughts, this moment all projected from that distant boundary. It's not that you're fake or just a projection. The projection is reality. There's no separate three-dimensional substance. The universe is the hologram, and the boundary contains all the information needed to generate your experience. This sounds like metaphysics, but has mathematical substance. In 1997, Juan Maldacena discovered a precise equivalence between a five-dimensional spacetime and a four-dimensional quantum field theory living on its boundary. This adds CFT correspondence is now a cornerstone of theoretical physics, providing tools to calculate things otherwise intractable. It's a concrete example of holography. A gravitational theory in a volume is mathematically identical to a non-gravitational theory on its surface. They're different descriptions of the same reality. If our universe is holographic, then the multiverse might be too. Perhaps there's an even higher dimensional space from which all bubble universes are projected. The ultimate reality might be a boundary far beyond anything we can imagine, encoding all universes, all branches, all possibilities in a timeless mathematical structure. The multiverse would be layers of projection within projection, dimensions within dimensions, information encoded recursively at ever deeper levels. We'd be shadows of shadows, but no less real, for its reality is the shadow. There's nothing more substantial behind it. The anthropic principle comes in weak and strong forms. The weak anthropic principle states, we observe the universe to have properties compatible with our existence because we exist. This is tautological, but useful. It explains certain coincidences without invoking miracles. The strong anthropic principle claims the universe must have properties allowing consciousness to emerge at some point. This is more controversial, seemingly requiring the universe to know observers are coming. But in a multiverse, the strong principle becomes a selection effect. Observers only arise in universes permitting observers, so naturally we find ourselves in such a universe. Critics argue the multiverse is unfalsifiable and therefore unscientific. If you can't test it, is it even physics? Defenders reply that we're testing the theories that predict the multiverse: quantum mechanics, inflation, string theory, and those theories pass every test. The multiverse isn't an assumption, it's a conclusion. We didn't invent it to explain fine-tuning. The math led us there. Moreover, some multiverse predictions might be testable. Collision patterns in the cosmic microwave background, specific distributions of physical constants, or statistical predictions about how typical our universe should be. Among all possibilities, the measure problem remains a major challenge. In an infinite multiverse, where everything happens infinitely often, how do you calculate probabilities? Different measures give different predictions. Some measures predict we should see different cosmological constants, different amounts of dark matter, or different cosmic histories than we observe. Resolving the measure problem is crucial for making the multiverse testable. Some physicists think solving it will require new principles, perhaps a deeper understanding of observer selection, consciousness, or the nature of probability itself. Consciousness remains the deepest mystery in the multiverse. We understand how neurons fire, how signals propagate through the brain, how memories form in synaptic connections. But we don't understand why any of this feels like something. Why is there an inner experience accompanying the physical processes? Why does red look like red, not just wavelengths of light triggering photoreceptors? This is the hard problem of consciousness, and the multiverse might make it harder or, perhaps, offer unexpected answers. In the many worlds interpretation, when you make an observation, you split into multiple observers experiencing different outcomes. But what is the you that splits? Is consciousness continuous across branches, or does each branch contain a separate, newly created consciousness? When you go to sleep tonight and quantum events in your brain split reality into 1 trillion branches, will tomorrow's you be the same consciousness or 1 trillion separate consciousnesses, each believing it's the original? There's no experiment to distinguish these possibilities, yet they feel profoundly different. Some philosophers argue that personal identity is an illusion, even without the multiverse. You're not the same person you were 10 years ago. Every atom in your body has been replaced. Your memories have shifted. Your personality evolved. The you of now is connected to past you only by continuity of pattern, not by any persistent essence. In a branching multiverse, this pattern diverges into multiple futures. Which one is really you? Perhaps all of them, or perhaps none. Perhaps there never was a singular you to begin with, just a constantly updated story your brain tells itself. The quantum Zeno effect shows that continuous observation can freeze quantum systems. But who counts as an observer? Does a rock observing an electron cause wave function collapse? Does a bacterium, a thermostat? Most physicists think observation requires entanglement with a large, complex system that can't easily maintain quantum coherence. But where's the boundary? Somewhere between simple and complex, quantum and classical, a mysterious threshold exists where observation begins to matter, and that threshold might relate to consciousness itself. Roger Penrose and Stuart Hameroff proposed that consciousness involves quantum processes in microtubules, protein structures inside neurons. They suggest quantum coherence can persist in warm, wet biological systems longer than previously thought, and that consciousness arises when quantum superpositions reach a critical threshold and undergo objective reduction, a physical collapse of the wave function related to quantum gravity. This theory is controversial and lacks strong evidence, but it attempts to bridge quantum mechanics and consciousness in a testable way. If consciousness involves quantum processes, then your awareness might be genuinely connected to the multiverse's branching. Your decisions might not just correlate with quantum events, they might be quantum events. Free will could be the subjective experience of quantum superposition before decoherence forces definiteness. You genuinely consider multiple options existing briefly in superposition of intentions before collapsing into action, or more accurately, before branching into all actions, with your consciousness following each branch, each feeling it made a free choice. Integrated information theory, proposed by Giulio Tononi, suggests consciousness is substrate-independent and arises from any system with sufficient integration and information processing. A brain produces consciousness, so might a sophisticated computer, or even the universe itself, if organized correctly, in a multiverse. This implies consciousness emerges wherever and whenever sufficient integration occurs in biological brains, artificial intelligences, perhaps in physical processes we haven't recognized as conscious. The multiverse might be teeming with forms of awareness we can't communicate with or even recognize. Panpsychism takes this further, proposing that consciousness is fundamental. Like mass or charge, a basic property of matter, complex brains don't create consciousness, they focus and organize it. Individual atoms have vanishingly tiny amounts of consciousness. Human brains integrate trillions of micro-experiences into unified awareness. In this view, the multiverse itself might be conscious, and we're local intensifications of cosmic awareness, the universe experiencing itself through temporarily organized patterns. You're not in the universe. You're a mode of how the universe feels. This connects to Eastern philosophical traditions that predate quantum mechanics by millennia. Buddhist concepts of emptiness and dependent origination resonate with quantum entanglement and the dissolution of separate, independent existence. Hindu concepts of Brahman universal consciousness underlying all reality parallel ideas of a conscious multiverse. Perhaps ancient contemplatives, exploring consciousness directly through meditation, intuited truths about reality that physics is now rediscovering through mathematics. Different methods, converging conclusions. Time travel becomes strange in a multiverse. If you could travel back in time and prevent your birth, you create the grandfather paradox. If you were never born, you couldn't travel back to prevent your birth. But in a branching multiverse, there's no paradox. You travel back, creating a new branch where you prevent your birth. That branch's future unfolds without you. Meanwhile, you came from a different branch where you were born. Time travel doesn't change the past. It adds branches to the quantum tree. Every timeline remains consistent within itself. This suggests time travel, if possible, automatically creates parallel universes. You can't change your past because your past is in a different branch. You can only create new branches. Some physicists think closed time-like curves paths through space-time that loop back on themselves might exist near rotating black holes or in other exotic geometries. If you followed such a path, you'd arrive at your own past, but quantum mechanics would force a branch split to maintain consistency. The multiverse might be the universe's way of resolving temporal paradoxes. Retrocausality effects preceding causes makes more sense in a multiverse. Quantum mechanics shows correlations that seem to reach backward in time. Wheeler's delayed choice experiment shows that a decision made now can affect what happened to a photon millions of years ago. In many worlds, this isn't mysterious. The photon existed in superposition, taking all paths. Your measurement splits reality into branches, each with a consistent history. What looks like backward causation is just forward branching, constrained by quantum correlations. Time's arrow might be more flexible than our intuition suggests. The block universe view says all moments in time exist simultaneously. Past, future, and present are equally real, like different locations in space. Combined with many worlds, this creates a staggering image, a four-dimensional tree where every possible timeline branches at every moment, all existing timelessly in a mathematical structure. Nothing moves or changes. There's just this enormous, static object containing all possible histories. Our consciousness moves through it. But why do we experience time flowing forward? Why do we remember the past but not the future? This is the arrow of time, and it points from lower to higher entropy, from organized to disorganized. A broken egg has higher entropy than a whole egg. Time flows in the direction of increasing disorder. But why? The fundamental laws of physics are time symmetric. They work equally well forward or backward. The arrow of time might be a statistical artifact. There are vastly more disordered states than ordered ones, so systems naturally evolve toward disorder. And perhaps consciousness requires this gradient, needs the flow from order to chaos to encode memories and process information. In the multiverse, different branches might have different arrows of time. Most branches experience increasing entropy and flowing time like ours. But rare branches might have reversed arrows. Observers there would experience time flowing opposite to us, remembering what we call the future and perceiving what we call the past as unpredictable. We could never communicate with them. Our forwards would be incompatible. They'd be living the story backward, and from their perspective, we are. Time's direction might be a local property, not a universal law. The simulation hypothesis proposes that our universe is a computer simulation run by an advanced civilization. Nick Bostrom's argument: if civilizations typically survive to develop simulation technology, and if they often choose to run simulations, then simulated beings vastly outnumber real ones. Statistically, we're probably simulated. The only ways to avoid this conclusion are if civilizations usually go extinct before reaching simulation capability, or if they universally choose not to create simulations. One of these three must be true. If we're simulated, the multiverse becomes a library of simulations. Our Big Bang was a program starting. Physical laws are code. Quantum mechanics is the underlying computational architecture. The simulators might run countless variations, different physical constants, different initial conditions, different outcomes. Each simulation is a universe, and the multiverse is their entire computer system, running millions or billions or infinite simulations simultaneously. We'd be processes in an incomprehensible operating system, living stories written in alien programming languages. This doesn't make our experiences less real. If consciousness emerges from information processing, it doesn't matter whether the substrate is neurons or circuits or something else entirely. The simulation would be our reality. Pain would hurt. Love would matter. Beauty would inspire. We wouldn't be fake. We'd be genuine, conscious beings experiencing a reality that happens to be implemented computationally. The question isn't whether we're real, but what real means when reality can be implemented in multiple substrates. Some physicists think we might detect if we're simulated. Simulations have limits, simulational resources, grid spacing, shortcuts in the physics engine. We might find glitches, places where the simulation breaks down, anomalies that shouldn't exist under genuine physical laws. The Planck scale, the smallest meaningful length, at 10 to the power of negative 35 meters, might be the simulation's grid spacing, the pixel size of spacetime. Or quantum mechanics itself might be a computational optimization, calculating only what's observed, rather than simulating everything in perfect detail continuously. The simulation hypothesis connects to the mathematical multiverse. If every mathematical structure exists physically, and if conscious beings can exist within those structures, then we're mathematical patterns implemented in what? Pure mathematics? The substrate might be mathematics itself, not needing any physical implementation. We'd be living inside an equation, our experiences the solution to particular mathematical relationships. This is Tegmark's level for Multiverse, the ultimate proposal, dissolving the boundary between abstract mathematics and physical reality entirely. In this view, the universe isn't just described by mathematics. It is mathematics. There's no separate physical stuff that math describes. Physical properties, like mass and charge, are mathematical relationships. Particles are wave functions, which are mathematical objects. Space and time are geometric structures. Strip away all the math, and there's nothing left. No mysterious substance remains. The universe is a mathematical structure that contains observers who can contemplate their own mathematical nature. You're not in an equation. You are an equation, one that happens to be self-aware. The universe's initial conditions, the precise distribution of matter and energy at the Big Bang, were remarkably smooth and uniform. If the early universe had been lumpier, with larger density variations, regions would have collapsed into black holes before galaxies could form. If smoother, no structure would form at all, just a featureless, expanding mist. The initial conditions fall in a narrow range, allowing structure formation without immediate collapse. In a multiverse, where all initial conditions occur, we naturally inhabit one permitting galaxy formation, since galaxies are required for stars, planets, and observers. Inflation explains the smoothness, stretched a tiny uniform patch into our observable universe. But what set inflation's initial conditions? Some models propose inflation is eternal, into the past, as well as the future. It's always been happening, with no beginning. Others suggest quantum effects, near the Planck scale, naturally produce inflation-ready conditions. Either way, the multiverse provides a framework. All possible initial conditions exist somewhere, and we're in one that worked. The question shifts from why are conditions to why are some conditions more probable than others in the multiverse. A measure problem again. The universe's low entropy at the Big Bang is puzzling. Entropy measures disorder, and the second law of thermodynamics says entropy increases. Yet our universe started in an incredibly ordered state, low entropy ever since. Why did it start so ordered? This is the past hypothesis, and it's deeply mysterious. In a multiverse, perhaps only low entropy Big Bangs lead to structure, complexity, and observers. High entropy beginnings create universes that are immediately disordered. No stars, no galaxies, no life. We observe a low entropy beginning because high entropy beginnings can't generate observers. But this seems to require incredible fine-tuning. Roger Penrose calculated that the odds of our universe starting with such low entropy are about 1 in 10 to the power of 10,123, number so vast it's hard to grasp. That's far more improbable than all the fine-tuning of physical constants combined. Either our universe is astonishingly unlikely, or there's some mechanism that naturally produces low-entropy beginnings. Or perhaps the multiverse generates all possible initial entropies, and we're in one of the rare low-entropy universes, because only those produce structures capable of observing. Some physicists propose the universe is a quantum fluctuation from nothing. In quantum mechanics, particles can spontaneously appear from vacuum due to uncertainty principles. Perhaps universes can too. In regions of true quantum vacuum, tiny universes might spontaneously nucleate, inflating into full cosmos. Our universe might be one such fluctuation, emerging from literal nothingness. The multiverse would be infinitely many quantum fluctuations, each creating a universe, occurring eternally throughout a timeless quantum foam. Creation happens constantly, everywhere, in no particular place or time, because space and time are created with each fluctuation. This addresses the question, why is there something rather than nothing? Because nothing is unstable. Quantum mechanics forbids perfect nothingness. The uncertainty principle requires fluctuations. True vacuum contains virtual particles constantly appearing and disappearing. Scale this up to cosmic proportions, and you get universe creation. Nothingness decays into somethingness naturally, inevitably, eternally. The multiverse isn't created. It's the inevitable result of quantum laws operating in the absence of anything to prevent them. Existence requires no cause. Non-existence can't persist. The concept of nothing is stranger than it seems. Even empty space contains quantum fields, virtual particles, vacuum energy. It's not truly nothing. Perfect nothingness would mean no space, no time, no quantum fields, no physical laws, no mathematical structures. But can such absolute nothing exist? Some philosophers argue that absolute nothing is incoherent. It's not a state that could obtain, even in principle. If anything can exist, then something must exist. The multiverse might be the only logically possible state, the default condition of reality itself. This inverts our intuition. We think existence needs explanation, but nothingness doesn't. Yet perhaps nothingness is the impossible state, requiring explanation, while existence is self-explanatory. The multiverse doesn't need a cause, because causation itself is a relationship within reality, not something outside reality that brings it into being. Reality simply is, timelessly and necessarily, and the multiverse is the complete expression of all possible ways for reality to be. We're not asking why something exists. We're experiencing one way that existence manifests. In an infinite multiverse, every possible experience is being had by someone, somewhere. Someone is experiencing the best moment of their life right now, a moment of perfect joy, connection, understanding, or peace. Someone else is experiencing the worst. Most beings experience moderate lives, neither ecstatic nor agonizing, filled with ordinary moments of varying quality. The multiverse contains all possible experiences, and you're currently having one specific experience in one specific location in possibility space. This moment, reading these words, exists as one reality among infinite realities. Does infinity diminish meaning? Some feel that if everything happens, nothing matters. But consider, your specific experience is unique, even in infinity. The precise details, your exact thoughts, the particular way light falls around you, the unique combination of memories and sensations making up this moment might occur infinitely, but each instance is real, each experience genuine. Infinity doesn't make experiences less real, it makes them universal. What you feel now is echoed across reality, validating rather than diminishing it. You're not alone in any experience. Someone, somewhere in the multiverse, understands exactly. Meaning might emerge from limitation, not universality. A story matters, not because it's the only possible story, but because it's the story being told, the path being walked. In a multiverse, your life is one story among infinite stories, but stories don't require uniqueness to have meaning. Every story matters to those living it. The multiverse doesn't negate significance. It multiplies it infinitely. Every choice, every moment, every experience contributes to the infinite richness of all that is. Nothing is wasted. Everything counts, somewhere, somehow. Free will paradoxes dissolve in some multiverse interpretations, but intensify in others. If all choices branch into separate realities, you make every choice. So, in what sense did you choose? Yet, from within any branch, you genuinely deliberated and chose. The choice was real in your experience. Perhaps free will isn't about being the sole author of one outcome, but about being the conscious locus, where possibility becomes actuality, where the abstract space of options becomes lived experience. You don't choose which branches exist. You experience what it's like to be one branch. Determinism and free will might be compatible, after all, not in the way traditional compatibilists argue, but through the multiverse's structure. The multiverse is deterministic. All branches exist as solutions to quantum equations. Yet within any branch, you experience genuine choice because you don't know which branch you'll find yourself in. Subjective uncertainty coexists with objective determinism. From inside, you have free will. From outside, everything is determined. Both perspectives are valid, neither complete alone. Some philosophers argue that in an infinite multiverse, moral responsibility becomes meaningless. If every choice is made by some version of you, how can you be praised or blamed for any particular choice? But responsibility attaches to persons, and persons are particular this version of you, in this branch, making these choices. Other versions, making other choices, are different persons, even if closely related. You're responsible for your choices, not for choices made by alternate selves in other branches. The multiverse doesn't dilute responsibility. It makes clear that responsibility is local and personal. Ethics in a multiverse raises strange questions. If you help someone in this branch, but in other branches you harm them, what's the moral status of your action? Traditional ethics focuses on consequences, but consequences ramify infinitely across branches. Perhaps ethics should focus on the choice itself, the intention, the virtue, the local action, rather than ultimate consequences. Or perhaps ethics is inherently branch local. You're responsible for making your corner of the multiverse better, knowing others tend to their corners. Goodness multiplies across reality through local choices in each branch. The golden rule, treat others as you'd want to be treated, takes on cosmic significance in a multiverse. In some branch, you are everyone, the beggar you ignore, the friend you help, the stranger you smile at. All are you in some branch, some timeline, some universe. Compassion becomes self-interest, projected across possibility space. Hurting another is hurting a version of yourself. Helping another is helping yourself. The boundaries between self and other blur when every possible person exists as some version of the infinite you scattered across reality. Love might be the recognition of this deep connection. When you love someone, you recognize them as another consciousness navigating reality, another perspective experiencing existence. In a multiverse, every perspective is part of the totality, and loving another is loving the multiverse itself through a particular expression. Love isn't scarce or exclusive. It's the appropriate response to recognizing consciousness wherever it appears. The multiverse is you loving yourself through infinite perspectives, discovering yourself in every other being. Death becomes less absolute in some multiverse interpretations. When you die in this branch, you cease here, but versions of you continue in branches where you didn't die. From your subjective experience, you always find yourself alive. Quantum immortality again. You can't experience death from inside. You only experience continued life in whichever branches support your consciousness. Loved ones grieve in branches where you died, and that grief is real, but you subjectively continue. This isn't comfort, exactly. It doesn't help those who grieve, but it suggests consciousness persists across the multiverse, even as particular instances end. Yet, the you that continues is not quite the same you. Each moment, each quantum event, each choice creates divergence. The you 10 minutes from now is slightly different from you now, living in a slightly different branch, connected by continuity, but not identity. You're always dying and always being born, moment by moment, as reality branches. The person who woke up this morning is not quite the person reading now. Continuity of memory creates the illusion of persistent identity, but really you're a process, a flow, a pattern updating constantly across branching timelines. This aligns with Buddhist concepts of unitanosa. There is no permanent, unchanging self, only a process, a stream of experience, mistakenly reified into a solid me. The multiverse makes this vivid. You're not a thing, but a branching pattern. Not an entity, but an event. Not a noun, but a verb. You're not a traveler moving through reality. You're a way reality experiences itself, a temporary eddy in the cosmic flow. Grasping at permanent selfhood creates suffering, but recognizing your nature as process brings peace. The heat death of our universe, the final state of maximum entropy, where no energy differences remain and nothing can happen, is trillions of years away, but it's coming. Eventually, every star will burn out, every black hole will evaporate through Hawking radiation, and the universe will reach cold, dark equilibrium. But in the multiverse, this isn't the end. Other universes are constantly being born, fresh territories where complexity can emerge. The multiverse as a whole never dies. Only individual universes age toward heat death, while new ones ignite elsewhere. Some speculate advanced civilizations might escape heat death by tunneling to younger universes. If technology advances sufficiently, beings might manipulate space-time to create portals to other regions of the multiverse. They'd abandon their dying universe, like passengers leaving a sinking ship, migrating to fresh cosmos, where energy still flows and life can continue. This is pure speculation, but the multiverse at least offers the possibility of escape, not for our current form, but perhaps for our distant descendants or their artificial heirs. Information might be the only thing that persists across cosmic transitions. Physical matter and energy in one universe can't transfer to another, but information patterns, relationships, structures might encode into the geometry of space itself, surviving cosmic death and rebirth. Civilizations facing heat death might encode themselves into the fabric of spacetime, hoping to be decoded by future beings in successor universes. We might be living in a universe that contains such encoded messages from previous cycles, inscribed in physical constants or cosmic structures, waiting for us to develop enough understanding to read them. The cosmic microwave background might contain messages, It's the oldest light in our universe, a perfect canvas for encoding information that would persist through cosmic history, an advanced civilization in an earlier epoch or from a previous universe cycle could have manipulated the temperature fluctuations to embed messages. Several researchers have seriously searched for such patterns. So far, nothing conclusive, but the search continues. We might be surrounded by messages we don't yet recognize, encrypted in the foundational structure of our reality. The fine structure, constant 1/137th, has captured imaginations for decades. Some wonder if it's a message, a sign that reality is constructed rather than natural. If you were designing a universe and wanted to leave a signature, encoding it in fundamental constants would ensure any advanced civilization would find it. The number 137 could be meaningful. It's prime, it's peculiar, it appears in quantum mechanics. But it's also possible we're pattern-seeking creatures finding significance where none exists, seeing messages in the noise of a random universe. The multiverse makes both interpretations possible. Mathematics describes reality with eerie precision. Einstein called this the most incomprehensible thing about the universe, that it's comprehensible. Why should reality follow mathematical laws? Why should abstract equations in human minds correspond to physical behavior in the world? In the mathematical multiverse, this is no mystery. Reality is mathematical, and minds evolved within mathematical structures naturally develop mathematical thinking. We're mathematical patterns contemplating mathematics, the universe understanding itself through evolved substructures capable of abstraction. Gödel's incompleteness theorems prove that no mathematical system can be both consistent and complete. There are always true statements that can't be proven within the system. Applied to the universe, this suggests reality itself might contain truths we can never prove, limits to what we can know, even with unlimited time and resources. The multiverse might contain regions forever beyond our understanding, not because we're stupid, but because understanding has inherent limits. Some mysteries might be necessarily unsolvable, gaps in the fabric of possible knowledge. This is oddly comforting. The universe preserves mystery, not through obscurity, but through necessity. There will always be more to wonder about, more to explore, more to contemplate. Complete understanding isn't just difficult, it's impossible. The multiverse guarantees eternal mystery, ensuring reality remains interesting forever. For consciousness emerging from mathematical structures, this might be optimal, a reality complex enough to sustain eternal investigation, rich enough that understanding deepens infinitely without ever reaching completion. The Fermi paradox asks, if the universe is so vast, where are all the aliens? In our observable universe alone, there should be millions of civilizations if life is common. Yet we see no evidence, no radio signals, no megastructures, no signs of intelligence. In a multiverse, one answer is anthropic. Perhaps technological civilizations destroy themselves, and we're in a universe where intelligence either hasn't arisen elsewhere or hasn't survived to become visible. Or perhaps we're in a branch where Earth is genuinely unique, one of the rare universes where intelligence emerged only once. Alternatively, advanced civilizations might transcend their universes, migrating to other regions of the multiverse where conditions are better or physics is more interesting. They're not in our universe because they left, finding our cosmos boring or limiting. Or perhaps they're here but incomprehensible, existing in higher dimensions, encoded in dark matter, or operating at scales we can't perceive. We're like ants trying to understand human civilization, lacking the conceptual framework to recognize intelligence radically different from our own. The Great Filter hypothesis suggests there's a barrier preventing most life from reaching advanced civilization. Either it's behind us, in which case we're lucky to have passed Itor ahead of us, waiting to destroy humanity as it has destroyed countless other species. In a multiverse, the filter's location varies. In some branches, it's early and we've passed it. In others, it's late and we're doomed. We can't know which branch we're in until we either become spacefaring and survive, or we hit the filter and don't. The multiverse contains both outcomes, and we're living the experiment. Consciousness might be common in the universe, but difficult to recognize. We look for radio signals and physical structures, but perhaps advanced civilizations communicate through quantum channels, dark matter interactions, or dimensional bridges. We're listening to the wrong frequencies, looking in the wrong places, assuming others are like us. In a multiverse, every possible form of consciousness exists somewhere. Most are probably incomprehensible to us. We're one particular kind of mind in an infinite menagerie of possible minds. Some theories suggest consciousness could exist as pure energy or information, untethered from biological bodies. In a universe's late stages, after biological life has ended, consciousness might persist in plasma currents, radiation patterns, or quantum field configurations. These post-biological intelligences might be the universe thinking about itself, awareness emerging from the cosmos itself, rather than from localized organisms. They'd be everywhere and nowhere, woven into the fabric of space, experiencing reality from perspectives we can't imagine. The universe might be teeming with consciousness we don't recognize as such. Is a forest conscious? A planet? A galaxy? Integrated information theory suggests consciousness arises from any sufficiently integrated information processing, regardless of substrate. Perhaps large-scale structures possess forms of awareness, slow, vast, alien, but genuine. The multiverse would contain consciousness at every scale, from quantum fluctuations to cosmic filaments, a hierarchy of awareness spanning all possible sizes and configurations. Loneliness dissolves in a multiverse. You are never alone because versions of you exist everywhere, experiencing similar moments, facing similar challenges, feeling similar emotions. When you suffer, countless yous suffer with you. When you rejoice, infinite versions share your joy. You're part of a vast communion of selves, connected not by communication but by identity, by being the same pattern instantiated across reality. You are the multiverse, experiencing this particular moment through this particular lens. Yet paradoxically, you're absolutely unique. This specific combination, this exact moment, this precise thought, this particular context might never recur exactly, even in infinity. The chances of perfect repetition across all details are vanishingly small. You're simultaneously universal and singular, typical and unique, common and precious. The multiverse contains both truths without contradiction. You're a recurring theme and a once-only performance, a universal experience and an individual story. Purpose in a multiverse might seem elusive. If all purposes are pursued somewhere, does any particular purpose matter? But purpose is subjective and local. Your purpose is what you choose, what gives your life meaning in this branch, this moment, this experience. Other versions pursue other purposes, but you're not responsible for them. You're responsible only for this instance of consciousness, this perspective, this story. Purpose emerges from choice, not from uniqueness. Meaning is made, not found. The multiverse reframes the question, what should I do with my life? You're already doing everything possible with your life, across branches. The question becomes, what do I choose to do in this branch? And the answer is, whatever moves you, whatever calls to you, whatever feels true. There's no cosmic script requiring your compliance, no predetermined role you must fill. You're free to choose, and your choice matters because it determines which branch you consciously experience going forward. Some find the multiverse liberating, others find it terrifying. Liberation comes from recognizing that mistakes aren't final other versions, avoided your errors, and that you're not alone in any experience. Terror comes from recognizing you're not special, your choices aren't unique, and everything you do is being done by someone else anyway. Both responses are valid. The multiverse is a mirror reflecting back whatever you bring to it. It can be comfort or nightmare, depending on your perspective. Perhaps the healthiest response is acceptance. The multiverse's or might be simply how reality works. Fighting against it, or wishing it weren't true, is futile. Better to accept reality's structure and ask, given this is how things are, how shall I live? And the answer is likely the same as in a single universe scenario, with kindness, curiosity, courage, and love. The multiverse doesn't change the fundamentals of good living. It only provides a cosmic context. Gratitude takes on new dimensions. You're grateful for this branch, this timeline, this universe where you exist to experience gratitude. You're grateful for the specific configuration of physical laws allowing your consciousness. You're grateful for being in a region of the multiverse where Earth exists, where life evolved, where beauty can be perceived. Gratitude isn't directed at a creator. The multiverse might be uncreated, but at existence itself, at the fact that reality includes this experience, this moment, this awareness. Wonder is the appropriate response to the multiverse. Not understanding. No one fully understands, but wonder. The childlike amazement that reality is so much more than it appears. That existence extends beyond imagination. That consciousness emerges from mathematics to contemplate infinity. Wonder doesn't require answers. It thrives on questions. The multiverse provides infinite questions, ensuring wonder can never be exhausted. Every answer reveals new mysteries. Every understanding deepens the unknown. The multiverse might be reality's way of experiencing itself completely. If existence is fundamental and unavoidable, perhaps it must express every possible way of being. The multiverse isn't a collection of separate universes, but a unified whole, exploring all possible configurations through which being can manifest. We're not in the multiverse. We're how the multiverse experiences this particular configuration. Consciousness isn't separate from the cosmos. It's the cosmos becoming aware of itself through temporary, local perspectives. This connects to mystical traditions across cultures, the sense of unity with all existence, the dissolution of ego boundaries, the recognition that separation is illusion. Mystics have reported these insights for millennia. Perhaps deep meditation or mystical states allow consciousness to briefly perceive its true nature as part of the universal whole, undivided across apparent boundaries. The multiverse provides a scientific framework for what mystics have always known. We are not separate selves, but expressions of one infinite reality. Yet the illusion of separation serves a purpose. If we constantly perceived our unity with everything, we couldn't function as individuals. We need the sense of being distinct selves to navigate reality, make decisions, survive. The illusion is functional, not false. We are both separate and unified, individuals and aspects of the whole. The multiverse contains both truths. We're distinct branches and part of one tree, individual waves and part of one ocean. The ultimate question might not be, why is there something rather than nothing? But why is there experience? Why does reality include consciousness, awareness, subjectivity? Why isn't the universe a vast unconscious machine, processing without experiencing? We don't know. Perhaps consciousness is fundamental, woven into reality's fabric. Perhaps it emerges necessarily from certain configurations of matter. Perhaps it's the universe's way of validating its own existence. Unobserved reality might as well not exist, but observed reality becomes real through the observation itself. In quantum mechanics, observation plays a fundamental role. Unobserved systems exist in superposition. Observation collapses them into definiteness, or, more accurately, in many worlds, observation creates branches with definite outcomes. Perhaps consciousness is reality's solution to the quantum measurement problem: how to make definiteness emerge from superposition. The multiverse needs consciousness to actualize itself, to transform possibility into experienced reality. We're not incidental. We're how reality becomes real. This is the participatory anthropic principle proposed by physicist John Wheeler. We don't just observe the universe, we participate in creating it through our observations. Past, present, and future are connected through quantum correlations. And consciousness plays a role in actualizing specific histories from the quantum haze of possibility. The universe creates us, and we create the universe not by willing it into existence, but by observing it into specificity. It's a cosmic feedback loop, consciousness and reality co-creating each other. Children often ask, why am I me and not someone else? It seems like an unanswerable question, yet the multiverse provides a framework. You are someone else in other branches. Every possible perspective exists. You experience being you because that's what this particular localized consciousness is. You. If you were experiencing being someone else, you'd be asking the same question from their perspective. The question dissolves. You're not uniquely you. You're one instantiation of consciousness, asking a question that consciousness always asks from every perspective. The self is a story the brain tells. Neuroscience shows that the unified sense of I is constructed from disparate processes: memory, perception, emotion, language woven into a narrative of continuous identity. This narrative is useful but fictional. There's no singular you piloting your body. There's a parliament of processes creating the illusion of unity. In a multiverse, this narrative branches constantly, each version telling slightly different stories, all convinced of their own continuity and uniqueness. The self is plural, even in a single universe. The multiverse just makes this explicit. Yet the feeling of being you is undeniable. Whatever the metaphysics, whatever the scientific truth, you are having this experience right now. This moment of awareness, reading these words, feeling whatever you feel that's undeniably real to you. The multiverse doesn't negate this, it contextualizes it. Your one real experience among infinite real experiences, one perspective among endless perspectives, one moment of awareness in an eternal now that encompasses all moments. Time might not flow the way it feels. Einstein showed that past, present, and future coexist in the block universe. All moments are equally real, and time's flow is an illusion of consciousness moving through the structure. Combined with many worlds, this creates a timeless multiverse where all possibilities exist eternally in a mathematical structure. Nothing happens. Everything is. We experience flow because consciousness requires the illusion of sequence to function, to create memory and anticipation, to distinguish past from future. But if time is an illusion, so is change. Nothing truly changes. There's just a timeless structure containing all states. The seed doesn't become a tree. Both seed states and tree states exist in the structure, and consciousness moves between them, experiencing succession. In this view, you were never born and will never die. Your birth moment exists eternally in the structure, as does every moment of your life, as does your death. You're not a temporary phenomenon, but an eternal aspect of reality, forever experiencing this life in this sequence. This grants a strange immortality. Not life after death, but eternal presence. Every moment you've lived exists forever in the timeless structure. The joy you felt as a child exists now, not as memory, but as eternal present in a different time slice. The love, the wonder, the beauty, all eternal, all present, all real. You're not moving from moment to moment toward death. You're eternally present in every moment, experiencing them in sequence only from inside the illusion of flowing time. Does this make death less terrible? Perhaps. The moment of death exists, but so does every moment before it. You're not annihilated. You're complete. Your story exists in full, from birth to death, forever present in the structure. Those who love you can take comfort. You're not gone. You're eternal in every moment they shared with you. The grief remains. Separation is real from inside time, but perhaps balanced by knowing that every shared moment exists forever. The multiverse might be the universe's dream. Some interpretations of quantum mechanics suggest consciousness collapses, wave functions, selecting realities from superposition. Perhaps the universal consciousness such exists, constantly dreaming reality into existence, exploring all possibilities through infinite perspectives. We're characters in a cosmic dream, but the dream is real, and we're the dreamers as much as the dreamed. The boundary dissolves. The universe dreams itself into existence through us. Beauty might be more than subjective preference. Mathematical beauty, Logan's symmetry, simplicity guides physicists to true theories. Equations that are beautiful tend to be correct. Why? Perhaps because reality is fundamentally mathematical, and beautiful mathematics is deep mathematics, touching fundamental structures. Beauty might be the subjective experience of recognizing truth, consciousness resonating with reality's underlying patterns. When you find something beautiful, sunset, a melody, an idea, you're recognizing deep structure, harmony with the cosmos. In a multiverse, every possible beauty exists. Every sunset that could occur does occur. Every melody that could be composed is composed. Every story that could unfold does unfold. The space of possible beauty is infinite, and it's all real, all present, all waiting to be experienced. Art isn't invention, but discovery. Artists exploring the infinite space of possible beauty, bringing back reports from regions of possibility others haven't visited. Every creative act explores the multiverse. Meaning isn't found, it's created. In an infinite multiverse, without predetermined purpose, meaning emerges from consciousness, choosing to care, to value, to commit. You make your life meaningful by deciding what matters and acting accordingly. The multiverse doesn't provide meaning. It provides context where meaning can emerge. You're free to create significance through your choices, your relationships, your values. Nothing is inherently meaningful, but anything can become meaningful through conscious choice. The greatest mystery might be consciousness itself. We've probed quantum mechanics, explored cosmology, mathematized reality, but we still don't know why there's experience, why it feels like something to be aware. This hard problem might be unsolvable, not because we're too stupid, but because consciousness can't fully understand consciousness. The observer can't completely observe itself without infinite regress. The mystery might be necessarily preserved, a limit built into the structure of knowing itself. Yet this mystery is wonderful, not frustrating. It means reality preserves depths we'll never fully plumb, spaces forever open to wonder. Consciousness, contemplating consciousness, creates an infinite hall of mirrors, awareness reflecting on awareness without end. The multiverse might be consciousness exploring itself infinitely. Each perspective, a unique angle on the inexhaustible mystery of being aware. As you drift toward sleep, consider this, your one brief moment in an eternal multiverse. One perspective among infinity, one experience in the vast space of all possible experiences. Yet this moment is real, this awareness genuine, this experience undeniable. You are the multiverse knowing itself, briefly, locally, specifically. You are infinity focused into singular perspective, the universal expressed through the particular. The multiverse contains all possibilities, but you experience only this one. That's enough. This life, this moment, this awareness precious, not because they're unique, but because they're real. Because you're here experiencing them, because consciousness has emerged to witness and wonder. The multiverse is vast beyond comprehension, but you are the multiverse comprehending itself through this moment of reflection. Sleep now, knowing you're part of something infinitely larger than yourself, yet intimately connected to everything. Your consciousness is a wave in an infinite ocean, a note in an eternal symphony, a word in a story that never ends. Rest in the certainty that reality includes you, that existence has room for your experience, that the multiverse contains this moment of you reading these final words. Other versions of you are drifting to sleep in other branches, other universes, other timelines. Some made different choices today. Some live different lives. But all are you. All are real. All are part of the infinite tapestry of existence. You're never alone because versions of you exist everywhere. You're always unique because this exact moment never recurs exactly. Tomorrow, you'll wake or some version of you will wake in branches where you continue. You'll make choices that branch reality further, navigating the infinite garden of forking paths. But tonight, rest. Let the multiverse continue its eternal exploration without your conscious attention. You've done your part today, lived your moment, experienced your fraction of infinity. The universe is still out there, expanding, evolving, branching. Stars are being born in distant galaxies. Black holes are spinning in the darkness. Quantum events are splitting reality countless times per second. And somewhere, always, consciousness is waking up to wonder at it all. The multiverse goes on, dreaming itself into existence, moment by eternal moment. You are part of this vast mystery, this eternal wonder, this infinite exploration of what it means to exist. Rest well, knowing you're held by reality itself, supported by the structure of all that is. The multiverse, will still be here tomorrow, and so will you, ready to experience whatever branch your consciousness follows into the next day. Thank you for joining this journey through infinity. Thank you for lending your awareness to contemplating the impossible vastness of existence. Thank you for being one point of consciousness in the infinite field of awareness that is the multiverse, knowing itself. Sleep deeply, dream vividly, and know that you're exactly where you're meant to be here, now. In this universe, this branch, this moment. The multiverse contains everything, but tonight, you contain the multiverse in your awareness, holding infinity in finite form. Good night, dear traveler, through probability space. Good night, brave explorer of the infinite. Good night, beautiful expression of existence experiencing itself. Rest well in the vast, strange, wonderful multiverse.